trigonometry, and welcome to part 2 of our video for 8.6, which is the dot product and its uses. Part 1, you learned about the dot product, did some examples on it. I'm pretty sure you guys felt it was pretty easy. But now we're going to talk about how the dot product can be used. First let me refresh you on stuff. You guys will probably remember from last week, anytime we had to find the magnitude of a vector, or basically how long or how strong its force was, you had to use this formula. Or in other words, to find the magnitude of a vector, you had to do the square root of a squared plus b squared, where the a and the b came from your vector. It turns out, now that you guys know how to do the dot product, there actually is a second way to find the magnitude. And basically, to find the magnitude, you can actually just take the dot product of your vector, or in other words, take your vector, copy it twice, and then do the dot product. Let me show you on the next slide how that works. So here we got the vector u, and we need to find its magnitude. I'm going to do this twice. I'm going to show you how we find the magnitude the old way, and then the new way with the dot product. So let's first do the old way. To find the magnitude of u, you had to do a squared plus b squared, where 5 would be the a and negative 9 would be the b. So then you do 5 squared plus negative 9 squared and go from there. You get the square root of 25 and then plus 81, and 25 plus 81, that should get you the square root of 106. That should be right, 25 plus 81, 106. Good. And also, you can try and simplify this as you can, but I'm going to tell you right now, we cannot break this down at all. You keep it just as it is. So that's the old way of finding the magnitude. You guys remember that from last week's video. But now, according to this, it says we should find the same magnitude if we were to take the vector u and do the dot product on itself. Or in other words, do 5, negative 9, 5, negative 9, and then do the dot product. Let's see if that works. Okay, so to do the dot product, gotta take the first numbers and multiply them to get 25. Take the second numbers and multiply them to get 81. And once you have those two results, you add them, just like we did in the part 1 video. And that will get you that the magnitude of u is the square root of 25 plus 81, as you guys can already see, it's going to be equal to 106. So in other words, this is basically just another way of finding the magnitude using dot product. Now, some of you are probably thinking, oh, I like the old way, I'll stick to the old way. That's totally fine. If you like the new way, go at it. So that is one way that we can use the dot product. However, the dot product actually serves a much, much greater purpose. But we'll get to that greater purpose later. I need to expose you to another example that you might come across on the HOX program. So let's say you have these two vectors and you need to find the magnitude and then add it to 4, rounded 2 decimal places. And just for skittles and giggles, I'm going to go ahead and find the magnitude using the new way. Or in other words, I'm going to do the square root of the dot product of u and u, and then whatever that is, add it to 4. And let's see, vector u is going to be negative 3, 3. Got it. Okay. So, going to take vector u, copy it twice, and then take the dot product of that, and whatever that is, I will then add it to 4. Multiply the first numbers, you'll get 9. Multiply the second numbers, you'll also get 9. And then add the two numbers. So then 9 plus 9 gives you 18. So you just got to do the square root of 18 plus 4. And yes, you'll have to compute that all the way, and HOX will ask for decimals. So let's go to our handy dandy calculator. You guys have seen this calculator tons of times already. eeweb.com/tool/calculator. We will be using this calculator quite a bit this time in this lesson, so make sure you have it ready. And also something else, make sure you have it in degrees. We are going to need that. But anyway, we currently just have to do the square root of 18 plus 4. So let's do the square root of 18, figure out what that is. Then we'll take the previous answer, add to 4. And that'll give us 8.2426. 8.2426. Hawks may ask you to round it to 2 decimals or 3 decimals. I'm just rounding to 4 just to be safe. But that's how you would tackle that problem. If you do the magnitude the old way, that's cool. But you just follow through like that, and that should be good. But now, back to what I was saying before. The dot product actually serves a much greater purpose. For example, let's say that you were given 2 vectors, vector u and vector v. And let's just say these were 2 random vectors, and you were told that you have to find the very precise angle between those 2 vectors. Now, looking at that, you're probably not sure what that angle would be. Well, it's definitely not 90 because it's an obtuse angle. Is it 120? Is it 135? Oh, what if it's a decimal? Oh, dear Lord. Have fun guessing that. If your angle turns out to be a decimal, whew, have fun guessing that. But yeah, no one has time to try and guess that, especially if there's no one there to tell you exactly what the answer is. So, let's say you need to find what that angle is, whether it be a decimal or not. This is how you can find it. So given 2 vectors, u and v, that share a common angle, the cosine of this angle can be found using this formula. So in other words, we have the cosine of theta. You can use this formula to find what the angle is going to be. You just have to use a little bit of cosine with it. But what you're going to end up doing is you're first going to take the dot product, then you're going to take the magnitude of u, and then multiply that by the magnitude of v. So once you have all 3 of these components, the dot product of u and v, the magnitude of u, and the magnitude of v, you would then take the first divided by the second and third products on bottom, and that would give you the cosine of theta. And then you can use that from there to determine what the exact angle is going to be. So in the next example, we'll be using this formula. So what I want you to do, I want you to go ahead and copy this formula off to the side. Write it on a separate sheet of paper so that you can easily glance at it on the next example. Go ahead, take a moment, write that formula down now. Okay, you should have paused the video, written it down. You should have it written down by now. So let's begin. I'm going to first begin by finding these 3 components. I'm going to find the dot product, I'm going to find the magnitude of u, and then the magnitude of v. Once I have those 3 parts, well then you put them in the formula. So, say you have this example that we're going to find the angle between these 2 vectors, and then round our answer in degrees to 2 decimal places. So the first thing I'm going to do, I'm going to go ahead and find the dot product of u and v. So u dot product with v. Let's go ahead and do that first. So here's u and v. Multiply the first numbers first. You'll get 48. Multiply the second numbers, -6 and -3, to get 18. And once you have those 2 numbers, you then add them together. And 48 plus 18 should give you 66. So there you go. That's the dot product of u and v. Good. So now, according to the formula, the next thing we're going to need is the magnitude of u. So let's go ahead and do that next. So magnitude of u. I'm going to go ahead and use the old way for this one, and then I'll do the new way for the magnitude of v. So magnitude of u, I'm going to use a squared plus b squared. where for u, this is a and this is b. All right, so I got to do negative 8 squared plus negative 36 squared. And that's going to give me the square root of 64. Why is it negative 36 squared? It should be negative 6 squared. There we go. And then add that to 36. Square root of 64 plus 36, that should get you 100. Ooh, look at that. Square root of 100, that's a perfect root. That's nice. So there you go. That's going to be the magnitude of u. The magnitude of u is just going to be 10. All right. Now there's one more component to find. We now got to find the magnitude of v. And the magnitude of v, I'm going to find using the new way, where I'm going to do the dot product of v. So v dot product v. Now real quick, what was v? V was negative 6, negative 3. So negative 6, negative 3, dot product, negative 6, negative 3. Okay? So then go from there. I'm going to multiply the first two numbers to get 36. Multiply the second numbers. Negative 3 times negative 3 is 9. And once I have those two results, add them. And that's going to give me the square root of 36 plus 9, which is going to be the square root of 45. And once we're here, you could simplify this down if you want, or break it down to get a perfect root. You can if you want to, but that's really not going to affect what our real answer is. Because remember, our real answer is we're trying to find what the angle is. So just for now, I'm going to keep it like that. I'm going to keep it as the square root of 45. Okay. So now back to the formula. We now have all three parts. Part 1, part 2, part 3. Now let's plug them into this formula and see what to go from there. Oops. Not going to do that. Okay, so scroll down, make some space. All right, so according to the formula, cosine of our angle is going to be equal to the dot product of u and v, and the absolute value of u times the absolute value of v. According to what we got, the dot product of u and v, if you scroll back up, the dot product was 66. Good. Then, got to take the magnitude of u, which if you scroll up, turned out to be 10. Then, we got to multiply that by the magnitude of v, which the magnitude of v, we got to be the square root of 45. All right? So that means we currently have that cosine of theta is equal to 66 times, or divided by 10 times the square root of 45. All right. Now, some of you are probably thinking, oh, that's my answer. I'm done. Oh, wait a minute. Remember, we're trying to find what the angle is, specifically just the angle. Not cosine of the angle, just the angle. So in other words, we got to figure out how to get rid of that cosine. Oops. And if you remember, in order to eliminate cosine, you have to use its inverse. So we got to do cosine inverse of both sides, and that will make cosine cancel, and that will leave you with just angle theta. All right. So now that's our objective. We can now find what theta is, and this is how we're going to do it. We're going to do 66 divided by 10 times 45, and then whatever that is, take the cosine. And please, whatever you do, do not type this entire thing into the calculator all at once. The calculator sucks at PEMDAS or PERMDAS. It sucks at it. It absolutely sucks at it. So my recommendation, I would do 10 times root of 45 first, then divide it 66 divided by that number, then take the cosine inverse. That is my advice. So let's go ahead and do that in the calculator. one step at a time. So we're first going to do 10 times the square root of 45. Okay. Now the next part, we got to do 66 divided by that answer. So 66 divided by the previous answer, where the previous answer was this. So let's do that and press enter. So we get that. So now we have computed all of this. Now we just got to do cosine inverse, and then we'll have it. So cosine inverse or arc cosine, same thing, a cosine of the previous answer. And make sure your calculator's in degrees, because that's what the problem asks for. Make sure your calculator's in degrees, then press enter. And that is our angle in degrees. Our angle is 10.30 degrees. It said to round to 2 decimal places. The third decimal is a 4, so we do not round up. So it's just 10.30 degrees. So write that here in the Hawks program. You'll write 10.30 degrees. And there you go. You now know how to find the angle of any two vectors that share a common point. So let's go ahead and try this one more time to get familiar with it. And then we're done for 8.6. Okay. So now we need to find the angle between these two vectors. Let's first find the 3 key parts. The first key part is that I had to find the dot product of these two vectors. So multiply the first numbers, you'll get 3. Multiply the second numbers, that will give you 24. And then add the 2 results, and you'll get 27. Awesome. That's the first part. So now we need the magnitude of u. And I'm going to do the old way first, where the old way was the square root of a squared plus b squared, where for vector u, a is 1 and b is negative 6. So I got to do 1 squared plus negative 6 squared, which will give you 1 plus 36, which will just leave you with the square root of 37. No need to simplify that. We'll just plug that into our final equation, and we'll be good. All right. And also, it's a prime number. You could even break it down anyway, even if you wanted to. So, now moving on to the third part. Now we've got to find the magnitude of v. And this time we're going to do the new way. We're going to do the dot product of v. Okay, so what is v again? It is 3, negative 4. So 3, negative 4, 3, negative 4, and I got to do the dot product. Okay, going from there. More space. There we go. Okay, so gotta multiply the first numbers first. That will give you 9. Multiply the second numbers to get 16. Add your 2 results together. And 9 plus 16 will give you square root of 25, which, lucky for us, is a perfect root, which means that the magnitude of v is just 5. Easy peasy for us. Okay, yep. Okay. Now we have all 3 parts. Now we can plug them into the cosine formula, where cosine of theta is equal to the dot product of u and v, and then the magnitude of u divided by the magnitude of v. And the dot product of u and v, we ended up getting 27 for this part. The magnitude of u, we got the square root of 37, and we got to multiply that by the magnitude of v, which the magnitude of v, we ended up getting 5. All right. So in other words, the cosine of theta is going to be equal to 27 divided by square root of 37 times 5. Okay? But remember, we don't want cosine, we just want theta. I have to get rid of that cosine, And I'm going to do it by taking the inverse of both sides. Okay, on this side, the cosines cancel, and I'm just left with theta. Now I got to do all the messy stuff on the right. I got to do square root of 37 times 5, and then whatever that is, I'll divide 27 by that number, then take the cosine inverse. Again, please take this one step at a time. Do not plug the entire thing in your calculator. So let's do it. Okay, I got to clear all this. I got to clear all that. So first, I got to do the square root of 37. And then I'm going to multiply that by 5. And that's going to give me that. So now I have this part. I now got to do 27 divided by that answer. So let's go to this. Got to do 27 divided by the previous answer. And then press enter to get that. So now we have all of this. Now I just got to take the cosine inverse of that answer. So cosine inverse, or a cosine, or arc cosine, same thing as the inverse. So cosine inverse is the previous answer, close parentheses. Make sure that your calculator is in degrees, and then press enter. Now it looks a little weird, but ignore this part. That's just the really, really long decimal stuff behind it. You just need to focus on this part. And you'll see closely that your angle is going to be 27.41 degrees. Because if you look at the third decimal, that's a 7. The 7 will make you round up to 4.1. So then that's the angle, 27.41 degrees. 27.41 degrees. So there you go. Now you see how the dot product serves a stronger purpose in finding any angle you want between two rays or two vectors. And it makes your life much easier. Much easier. And with that covers everything for 8.6. You can go ahead and do the online homework. And if you have questions, you just got to email me.